Welcome to BPPD. My name is Jorge Ortiz. This is going to be the first video in a series using Go code, where we'll be adding tests and we will be refactoring code in order to evolve it. So when you get into a new project and there's already an existing code base, the first thing you would like to do is probably to introduce some tests, if they are not there already, in order to understand how the code works and also in order to modify it in a safe way, this code. So these are going to be different parts of the same topic, and I will start by explaining how to find and how to exploit a sim. A sim is a part of the code that we can modify the behavior by using it in a different way. You will see how this happens when we talk about the testing. So I'm going to start by doing a very fast code review of an already existing application. The application is going to be one that is available for you, that you can download the repository from GitHub if you want to. And then I will define a possible evolution. I could even define a couple of them that would make sense for this application. And then I will use a sprout method in order to be able to modify the behavior to evolve things outside of the code that we are currently having in this implementation. And finally, I will show some example of an automatic refactoring to do that. The purpose of all of this is to add some tests, and this is what we are going to do in this first session. So let me remind you, this is not improvisation. I'm not going to pretend that I'm just watching the code for the first time and I'm doing this online for you. I have already reviewed a few code bases, and I was looking for something that was using obviously Go, that didn't have many tests, but that it was both at the same time, neither too complex nor too simple. So it had some business logic, it has some um, things that it was doing, but it was not too complex, so you can understand this pretty easily and then follow the explanation even if you haven't seen this code before. Well, I have taken some notes and I have prepared this concept, and the story that I'm going to tell you now is not the straight line that I draw when I was going through the process, but rather a summarized version of the process. I would like to start by thanking John Calhoun for sharing his code, because this is the code that I'm going to use. The code comes from one of his exercises in Gopher exercises, and you have the URL on the screen. If you want to go there, I recommend you to take his courses. But what I'm going to do is to start from one of the exercises that he did and try to evolve that into something different. And in order to do that, I will be introducing the tests. So what I ask you to do, if you want to follow the exercise and do it yourself, go to your Go path, use git clone in order to download the code base that we are going to work with. The code base is the one that he used for his task exercise when he was doing a command line application to do all tasks and to list the tasks that were still pending. And in order to work from the latest version of it, since what it is committed in GitHub is just the initial stage of the project, this is what it is in the master branch. I would like you to merge the solutions which are already in the repository, so we start from the finished product, so something that is already working. Well, you can stop the video here, do that, and if you wish to do the coding, then you will be up to date to work with me after that. The next thing that I would like to tell you is that this is I would like to summarize the purpose of this code by explaining which parts are composing the code base and what is the purpose of each of these parts. So briefly, since this is a command line interface, it has a root command that is under the command package, the CMD package, and it has three other commands, which are subcommands of the application. So since the task application is going to be able to list the pending tasks, to add a new one, and to do one of the tasks that are in the list, it has a subcommand for each one of them. So it has the list command, the add command, and the do command. All of them are using a BolDB database, which is a key value database, and the business logic, the tiny business logic that is inside of each commands is part of the command definition. You will see how in a moment. So our purpose is going to be to work to preserve the business logic when we are evolving this into a new application. So just to summarize, what is the architecture? The command line interface is constructed by using something, a package that is called Cobra. That, if I remember correctly, was written by Steven Francia. And then it uses BolDB, as I mentioned before, for the persistence. It could be any other database, but he chose to use BolDB. Good one. And well, if you take a look at the entities, in this case, the task, which is like the core of our application, it has no methods in it. It's just a plain structure with the data. And finally, as I mentioned before, the business logic is somehow embedded in the definition of the command. So it is not separated. And not only that, the commands depend on BolDB. So it has a double dependency, which is what we are going to try to break here in order to make this code base testable. So imagine that you have been hired by this company that has this beautiful command line application, and now they are going to ask you to evolve this application to add new features, because this is the purpose of your company, to have something that works as expected. And what you want to do here, for example, it could be to make this task application compatible with todo.txt standard. And this is an application that was created by Gina Trapani, and she documented very thoroughly. And there is an iOS version, there is a command line version, and there is an Android version. And I think that there are already versions in every programming language that you can imagine. But the goal here is not to use anybody else's but ours, and we're going to adopt this command line interface, which is going to write and read from a text file. That is the whole secret of the todo.txt. And instead of using the BolDB persistence, we are planning to use the todo.txt file in order to do that. So what we would like to do is to replace BolDB with this file persistence. How are we going to do that? Well, the strategy, I can separate two things here. I'm like the midterm strategy and the short-term tactics. So let's talk about strategy first, and then we will go into the tactics later. The strategy is going to be to separate the layers. I mean, you have a model, which is where the business logic of all these pieces should be. And then there's the persistence, which is, in this case, is the BolDB, but we are trying to replace this with writing and reading to a Bol database, to a to-do text file. And you have a user interface, which in this application is a command line interface, but it could be, let's say that it could be a web interface, and you're using a microservice using the same business logic and writing to Postgres. Why not? The goal here is to be able to use dependency injection properly and to make changes in the business logic as required, and use and reuse all the pieces as needed. That is the long-term or mid-term strategy. But if I mean, like usually when you get into a new project, you don't have a lot of time to do all these changes before you start adding the first feature to your project. Rather, you need to do something in an acceptable amount of time. So the short-term strategy would be, or the short-term tactics would be to introduce changes with small automatic refactorings that will help us to isolate from the command line interface, and to isolate our code also from BolDB. So breaking this coupling that the application has because of its simplicity. Um, it is important here that since we are going to do like the business logic is going to be the core of our application, everything else will have to depend on it instead of what it's doing now, that our business logic depends on BolDB. So in the process, we should avoid having circular dependencies. That would be a pain. And then we will introduce the new feature, which will be using another persistence and using more functionality that is standard, is assumed in todo.txt. Before I get into the code, I would like to recommend you a couple of books here. I have no relationship whatsoever with the writers or the publishers. I have happened to have met once Michael Feathers, but I don't know Martin Fowler. So these are books that I have used and I think they're good, and that's why I'm recommending them. I have no relationship. I have no particular interest in you buying them. But if you wonder where those techniques have, I mean, or you can find techniques similar to the ones that I'm mentioning here, or even the ones that I'm mentioning here, these are the books that I have used. So the first one is Working Effectively with Legacy Code, by Michael Feathers, and the purpose of this book is taking control of an existing code base. And that's what we are going to do here. And the second one is a catalog of existing refactorings, so you know how to replace the code with a very simple refactoring schema in a way that does exactly the same, that you can trust that it will do exactly the same, but that helps you to evolve this code in the way that you want that. So that's all for the books. One final comment before getting to the code. I'm not going to use it because I want to go to do this very fast here, but remember that if you do this, use Git as much as you want, because Git is going to be your friend. It's going to help you to come back in case you make any mistake. So do as many commits as you need in order to preserve the world. Anytime that you are in a safe situation, commit, commit, and commit again, okay? So let's start with the sims, and what we are going to do here is to have this to make the code work exactly the same, but have a point in the code where we can change the behavior so we can test that part. How are we going to, this is the definition of a sim. How are we going to do that? Well, we're going to extract a public method from the command, so that public method can be tested, and move the functionality to that public method, but the dependencies are not going to be inside of the method. Instead of being implicit dependencies, they are going to be explicit ones. And the purpose of that is that we can control these dependencies, and then the code is going to be easier to test. That's it. So without further ado, let me go back to the code, and this is what we are going to do here. I'm using Emacs here. If you go with Visual Studio or any other editor, be my guest. In this case, Emacs is going to do the work. As you can see here, I have already opened the project, but it is as you have downloaded it from the web. There's nothing happening here. And what I'm going to do is go to this command and show you what I was mentioning before. These 4 files that you have here, the root command, that is the one that accepts all of the subcommands and points you to each one of them, and then the list, the do, and the add subcommand that will do each of the tasks for this command line interface. In the DB folder, you have one file that is the one that takes care of the persistence of listing all the tasks, adding one, deleting one, and the main project starts with this Go file, as in any other case, which is very simple. It just uses the home directory and the DB path in order to create a DB path, and then creates an instance of your database and passes it to the commands. That's it. It creates an instance, and they pass to the from the main of the BallDB instance to the commands is implicit. There's no specific parameter that is passed on to the command to say this here you have your database. Okay, so the first thing that we're going to try to test here is the list command. And let me go here to the list command, which, as I said before, is using the Cobra command. It declares an struct, and this struct has a string for the command, the subcommand that you're going to use, a short description, and then the method that gets executed when this is used. Okay, so the business logic here it stays in these lines here between this and this curly brace. So you have here the first line is the one that is reading the list of tasks. Then it tests if there was any error testing the list of tasks, reading the list of tasks. If you don't have any task yet, then it just gives you a message. And if you do, it prints each of the tasks that you already have in the database. That's it. Okay, but this is business logic. This is what we want to preserve and test. I want to be sure that if I modify the code, I don't break this business logic. So how do I introduce tests so I'm sure that after each of the tests, after each of the changes that I do, I can run my tests and verify that this is still working properly? Well, the thing that I would like to do is to define here a different method, rather different function here that is going to be, list, that is going to be public. And this is where you are going to have all the business logic that I have just shown you. So the idea would be to get all these copied, get all these copied and have it here. So what is the problem with this? Well, first, one of my goals is to have the dependency on the DB to be explicit. So I cannot have this DB all task inside of my method. I rather have something pass on to this method that gives me this information without having to invoke the actual DB task. Why do I want to do that? Because then, instead of running against the actual BallDB instance, I can pass any information that I want in my test and then verify what happens if I return no task, if I return one task, two tasks, many tasks, So the idea here is to have something that I can pass that could be the data that I'm going to use. One idea would be to use the task, and that would be, DB task and an error, which would be error. Okay, so then I could use the parameters there after reading the method and pass them here. That is one option. Another option would be to use an interface and say that I pass an object that that provides the method all task, and that method returns task and so on. And there is a third one that I'm going to go with that one because I think is different. Okay, so instead of passing the actual data, I'm going to pass a function. I'm going to call this list function, LFN, and that is going to be a func, and is going to take nothing, and is going to return uh, an array or and a slice of dbtask and an error. Okay, and that is going to be my parameter. So if you are wondering why this is the signature of my function, well, the idea is that it's going to do exactly this, what all task is doing. So what I'm planning to do is to use this method as a parameter for this object here. And instead of calling dbtask here, I will be using lfn in order to obtain this data. And as you can see, the rest of the code is exactly what we have. So now I'm saving it, and here I'm going to invoke this code as I was doing before. So I'm going to use list, and I'm going to use the function, the method of the function of the package db that is providing me with all the tasks. That method is going to be db all tasks, and I can get rid of this part. Okay, so if I haven't done any mistake here, if I haven't made any mistake, I'm going to have exactly the same functionality just by extracting all the things into a public method that I can now test. Okay, and I not only can access this method from the outside, but also I have the dependencies, in this case, the information coming from the database, explicit. So let me save, and let me uh, compile this to verify that I haven't done any mistake. What did I do wrong? Oh, yeah, sorry. I did wrong that I was passing the invocation. The invocation gives a tuple, which are the results. And what I want here is not a tuple, but it's like the function that is going to provide me with this data. So that's good, because now I can compile again, and it would compile fine, and that's it. I now have something that does exactly the same by doing this automatic refactoring of extracting a method, public method in this case, and that's it. The only important thing is that I have preserved the free variables inside of this loop. Okay. The next thing that I'm going to do is to add some tests to this code. And that's going to be the last part for this session. And that is, first, I'm going to add a new file here that is going to be called list underscore test.go. So and in this file, which I'm going to open here, I'm going to declare this file as part of the CMD test. The reason why I want to have the underscore test here is that, as you know, in Go, you can only have one package per directory. The only exception is that you can have both a package and the package underscore test. So you can separate the test, and you can use your package by only having access to its public interface. And this is what I have, what I want to have here. I only want to access to the public interface of my package. So the things that I would like to do here is to create a simple test, and this test is going to be well, a very simple test. As I said before, there are four things that can happen here: that everything goes fine, and well, that it fails and it returns an error, and it prints the message and returns one. That it has no tasks, and then it prints a message, uh, always the same message, and that it has a list of tasks, one or more, and then it prints each one of these tasks here. If you want to put the first two things in the same test, you can. So you can verify that if something goes wrong, the message is printed and it exits. But this is hard to test. We will talk about it in another video. The first thing that I would like to try to do here is that if there are no tasks, then I get this message printed out. That's it. So I'm going to call this test list of no tasks prints message. Okay, so that is the full name of my method. And what I'm going to do here is, like in every method, I'm going to have an arrange part. I'm going to have an act part, and I'm going to have an assert part. The range is where I'm going to prepare all the stuff to be ready for the test. The act is when I'm going to exercise the method that I want to verify that is working as expected. In this case, it's going to be the list function that I mentioned before. And then I'm going to make an assertion. If the assertion is right, then I'm happy the test has passed. If the assertion is wrong, if it didn't pass, then it will print a message and the test won't pass, saying that what the error was. So what I'm trying to run here is the list command that I was mentioning before, and this is going to be the CMD, the name of the package, list. Okay, so far so good. So in order to run this command, I need to have a function that provides me with the data that I want. So let me declare this function here, and I'm going to call this LFN, and it's going to be a function that takes no parameters and returns an array of db task and error. That is the kind of function that I have said that I was going to use. And in this case, what this function is going to do is going to return an empty slice of db tasks, which I'm going to declare as this, and nil for the error, because it's not going to be any error when loading this data. So this is the function that I have declared, and I'm passing this on to this function, the list function. So LFN is the parameter I'm using here. Well, so we have defined what we needed. The dependency is going to act as a stub, and is going to do exactly what we were going to obtain. Then we are going to run the list, and what I'm expecting to happen is that I'm going to have the message, you have no task to complete, why not take a vacation, printed to the console. So, well, the problem is that I cannot read from the console here. I would like to get a message from here. And the problem is that this is not returned by the method, but rather it is used in the method to be printed to the standard out. So, well, I would like to use an auxiliary method that I'm going to call capture output that is going to invoke my other method, or rather a function with no parameters that in this case is going to use this method and is going to return whatever has been captured from the standard output. Well, and let's assume that we have this capture output, and I'm going to write it in a moment. When we have this method, what I'm going to assert is if the message that I got is what do I want it to be? Well, I want it to be exactly the same message that is going to be printed on the other side. But this is important. I'm going to go to the other window here, and I'm going to copy the message And here I'm going to define a constant that is going to be the expected message that is going to be equal to this. Okay? This will fail, and you will see why in a moment, but let's assume that this is the expected message. So if my message, the message that has been captured, is the expected message, is not the expected message, then I have had a problem. And what I'm going to do is to report that there is an error, and I'm going to use a wrong output. And what I'm going to do here is go to the next line, put a tab, and say my expected value was percentage s for a string, and then next line, tab, actual value, then percentage s for another string. And what I'm going to print here is the expected message and the message. Let's see. Oh, we need one other curly brace here, and that should be it. Okay, so this is what we want to our test to do. We are defining what is the expected message, defining a function that is going to act as we want. So it's going to just return an empty array or an empty slice of tasks. And then we are going to use that function to invoke the list, capture the output, and uh, compare that output with the expected one. If they are okay, if they are equal, that's fine. We pass. If they are not, then we create an error. Well, the last step that is missing here is the method that I'm going to use in order to create this capture, to be able to capture the information from the other function. So what I'm going to have here is a function that is going to be capture output, and that is going to take a function with no parameters, and that is going to return the string that is what is captured from the standard output. What I'm going to use here in order to capture is a pipe. So I'm going to use a reader, a writer, and an error. And these are going to be equal to OS pipe. So whatever is written to the writer, I can read it through the reader. That's a pipe. You talk on one side, somebody else hears you on the other side. Okay, so what we have here is this pipe, and what we are going to do is replace the standard output and also standard error, just to make simpler things for later, for replace this with the reader and the writer. So with the writer, and I'm going to use the reader to get the information. So the first thing that I'm going to use is to define a function, a variable that is going to hold the current OS standard output. The next thing is the standard error, and I'm going to put it here, OS standard error. Okay, so and there's one more thing that I would like to do before that, which is if error, well, since I'm in the middle of a test, if I cannot get a pipe, I'd rather panic and stop there. Okay, so if I don't get this to work properly, I'm going to complain. Now I have the standard output, the standard error preserved, and what I'm going to do is to be sure that if I leave this function, everything is where it was expected to be. So I'm going to declare a function with no parameters that I'm going to define here and that I'm going to invoke here. And in this function, what I'm going to do is the bringing back things to normality. So I'm going to use OS standard output equals standard output and OS standard error equals standard error. And well, just in case we change the login, we also would like to have set output, and we're going to use OS standard error. Okay, so this is when I leave, but now I'm going to do things to be able to capture this data. So what I'm going to do here is OS standard output is going to be my writer. Not only that, if if I have any error, I also want my error to be written to the standard error. And finally, if I have a log, I would like to be also written to the writer. That's it. Other than that, what I have to do is to be able to execute now the function, and it will write, instead of to the standard output, it will write to my writer. So I will use the reader to retrieve the information that has been written. How do I do that? Well, the first thing that I have to do is to create a Go routine that is going to take care of preserving the information there. So how is that done? Well, I create a variable that is going to be a buffer that is of type bytes buffer. No, not bytes. Bytes buffer. Yeah. And obviously, I need to make this. Okay. And this buffer is going to be used to copy the data from the reader. So what I'm going to have here is to OS copy, and the data is going to be in the buffer. So I want to pass the reference to the buffer. And what I'm going to read is a reader, sorry, and it's going to copy whatever has been written to the writer is going to be read, and the reader will have this information, and I can copy it to the buffer. And finally, I'm going to pass this through a channel to the outside. So let's first create the channel. I'm going to create a channel that is going to be make channel, and is going to be a simple string. And what I will do is to have this channel used to communicate the buffer that I have created here as a string. This is the Go routine that is taking care of reading the data while it's running. Okay, and here on the outside, what I will be doing is writing my f function, the function that let me show it to you here. The function that I create here, which I haven't named, by the way. So this function, and this function, I'm going to run it here, and once it has finished, what I will be doing is to return whatever is read from the out to from the channel, return it to the outside place. There's one more thing that I would like to do here, which is be sure that I close the writer. So I could do this here. I could use another defer, well, whatever. So the important thing here is that I close the writer. So let me summarize. In order to capture the output, I create a pipe. Everything that I write to the writer will I can read it from the reader. So I replace the standard output and the standard error with this writer. I execute the method, the function in this case, using this new version of the standard output, which is the writer. I have a routine that reads from the reader what has been written to the writer, and then I return the content of this thing that has been written. So that is my whole process, and what I plan to do here is to run this test. So let's cross fingers. It asks me if I want to save everything, and it's missing an argument. So it says that in line 48 is missing comma. This is 48. Oh, much better. So yeah, this should be it. And channel string, is that it? Oh, channel, much better. Sorry about that. So this is going to be OS copy, no copy. So I have already imported things here. And let me see. Oh, it's not OS copy. It is IO copy. Much better now. So again, let's run the test. Missing return at the end. Yes, please return. This is no Rust. And that should be it. And oh, so now my test is running, and still it is complaining that the output is not the same. But if you read here, it says you have no task to complete. Why not take a vacation? You have no task to complete. Why not take a vacation? What is the difference? Well, the difference is just that it's expecting to have exactly this string. And if I go to the original version here, I will see that it's printing ln. So it has a return, an end of line, after this message. So the only thing that is complaining about here is that there should be a slash n, backslash n, in order to make these two strings exactly the same. So let's try again. And if I didn't make any mistake, here you have it. The test passes. And that was exactly our goal. That's what we wanted to do. And this is what I'm going to finish with this session of coding. So I hope that you have seen that even though you have everything coupled, for a very simple program, it's okay, but that was what I was looking for. So I could decouple these two things. Even though originally the code was coupled, you have the ability to add tests by using this automatic refactoring, extracting the method, and you can now change and evolve your code, being able to trust that what you do doesn't affect to the previously existing code. And from there on, you can refactor all the way. You can not only refactor your code, but also your tests. So I hope that this has been useful. My goal is to create another maybe 2 or 3 more videos doing some more tests, introducing table tests here, having the database replaced, and a couple of things more that I think would make sense in the case of this project. But this really depends on you. If you think that this was worth and you want to watch anything else, then I would like you to click on the like button so I know that the time that I'm spending is worth that somebody else in the universe is watching these videos. So please, if you liked it, click on the like. If you think that something can be done better or something that I can add or remove from the content of this video is would help, just let me know. I hope to see you around soon and take care.